Today's lesson is going to build off of the previous lesson, which is identifying proportional relationships based on tables and graphs. So please add page 19 to your table of contents. And the front of the notes here are already pre-done. So just to explain where they came from, for our ratio, we're going to put the y value over the x value and simplify whenever possible. This one's already simplified, but the next ratio is 2/6. We can divide by 2, which will become 1/3. The next ratio is 3/9. Divide by 3, we'll get 1/3. And the last one is 4/16. Divide by 4, and you'll get 1/4. Therefore, the ratio y over x is not constant because they are not all the same. So it is not proportional. And here is our specific reason. 1/3 does not equal 1/4, and therefore it is not constant. This graph does not match the table. It's a separate graph, and we look to see if it's proportional. To be proportional, it has to be a straight line, and it has to go through the origin. So therefore, yes, this one is proportional. It is a straight line, and it goes through 0, 0. And here are the pre-written notes. I'd recommend highlighting where it's not proportional and then having that as the reason, and maybe highlighting the line and then highlighting straight line that goes through the origin. Now we're on the inside left of your notes. So if you open them up, we're going to look at if this table is proportional or not. So we're going to set up our ratios. Y over x, divide by 2, we get 1/25. 4/100, divide by 4, we get 1/25. 3/75, divide by 3, we get 1/25. And 1/25 is 1/25. So therefore, all of these are constant. So yes, it is proportional because the ratio y over x, 1/25, is a constant of proportionality. So that is a vocabulary word we'll be using. It's a constant of proportionality because all the values are the same. Example 2, please try this table. Set up the ratio. We have 18/6. Divide by 6, we get 3/1. 27/9, we get 3/1. 12/4 divided by 4, we get 3/1. And 15/3 divided by 3, we will get 5/1. So it was constant until the last coordinate. Therefore, it is not proportional because the ratio y over x is not constant. It is not a constant of proportionality because the values are not the same for all coordinates. So if you think about this, when we graphed in the last lesson, the graph would not be a straight line. So it might go through the origin if you connected here for this ordered pair, but then after we have 3, it's going to have a crooked part to the graph. Okay, example 3, you could go ahead and pause and try this one before seeing the answer. So our first ratio is 10/4. Divide by 2, we get 5/2. This one is 5/2. 15/6 divided by 3, we get 5/2. And 30/12 divided by 6, we get 5/2. And therefore, yes, it is proportional. And the graph would be a straight line that goes through the origin. So it is proportional. The ratio 5/2 y over x is a constant of proportionality. Example 4, once again, you could pause this video and try it before you see the answer. So the first ratio is 12/2, which simplifies to 6/1. 13/3 is simplified. So even if we didn't continue the table, we already know it's not proportional. But for note's sake, we're going to go ahead and continue and see that all of these values are not constant and therefore not proportional. So if you think about the graph, you look at this, you'd think maybe the graph is, all over the place, but in reality, it would be a straight line that just does not go through the origin. So this is not proportional because it looks like this, and we don't have the graph, so we're looking at the table. So our reasoning is the ratio y over x is not constant. It is not a constant of proportionality, meaning it is not the same for all values. Okay, on the right side of your notes, we have these graphs. So these ones are now a little quicker because we can look at the graph and know that it is a straight line and it goes through the origin. So yes, it is proportional because of those key factors. If you wanted more proof, you could look at ordered pairs on the graph. This ordered pair is y being 2, and the 1 is the x, so 2 over 1. And this ordered pair up here is 4 over 2. The coordinates are 2 comma 4, but y over x is 4 comma 2, and therefore it is 2 over 1. So it is a constant of proportionality as the ratio, and the graph, we can just look at it. Example 6, well, it is a straight line, but it does not go through the origin, so it is not proportional. So the reason you could say is no, although it is a straight line, it doesn't go through the origin at 0, 0. And then more proof, if we look at the ordered pair here, y over x is going to be 3 over 1. And then if we look at this next point up here, we're going to have 5 over 2, which is not equal to 3 over 1. Therefore, the ratio is not a constant of proportionality. And last but not least, looking at this, we see that it goes through the origin, but it is clearly not a straight line. So no, although the graph does go through the origin, it is not a continuous straight line. And once again, more proof, we have 1 over 1 here, but up here we have 3 over 4, y over x. Therefore, the ratio is not a constant of proportionality. And in class, they had to do an exit ticket.